In this lecture, we will continue our discussion on example of metric space. Let X comma D be a metric space. Let us define D. Define D as D1 as D1 xy is equal to dxy divided by 1 plus dxy. Then D1 is a metric on X. Given X comma D is a metric space and D1 xy is a function defined in terms of dxy by 1 plus dxy. We have to show D1 is a metric on X, that is D1 is defined in terms of the given matrix G on X, and we have to show D1 is again another metric in this space X. To show D1 is a metric on X, we have to show that D1 satisfies the three conditions for a function to be metric on a given space, that is non-negativity, symmetry and triangular inequality. First we are going to show non-negativity. Solution. Clearly D1 xy is greater than equal to 0, as D1 xy is equal to dxy by 1 plus dxy, and dxy is matrix, so this is greater than 0, 1 is greater than 0, their sum is this portion is greater than 0, so this sum is greater than 0, this is greater than 0, so D1 xy is greater than 0, and D1 xy is equal to 0 even only if this right hand side is equal to 0, that is dxy by 1 plus dxy is equal to 0, and this is equal to 0 if numerator is equal to 0, so this numerator is equal to 0. That means this matrix dxy is 0, this dxy is given matrix, as this is matrix, so this will be 0 only when x is equal to y. That means my first condition for D1 to be matrix is satisfied. I am going for the second one. So for second one, we have to show symmetry, that is D1 xy is equal to dxy by 1 plus dxy. Okay, and since D is a matrix, so this can be written as dyx. Okay, this is a metric, this satisfies symmetry, so dxy is equal to my dyx. So in case of dxy, I am writing everywhere dyx. Look here, in this function D1 xy is defined as dxy by 1 plus dxy. If I interchange the variable dyx by 1 plus dyx, my matrix will be D1 yx. So this is D1 xy. Here you should write the condition since D is matrix on X. Okay. Therefore, second condition is also satisfied. Now I am going to prove the third condition. Third condition. We know by the triangular inequality of the triangular inequality of d dxy is less than equal to dxz plus dzy. Okay, for all x, y, z belongs to x. Now if I take reciprocal of this relation, I will get this one. 1 by dxy is greater than equal to 1 by dxz plus dzy. Okay. Now I am adding 1 to both sides of this equation. I will get, adding 1 to both sides of this equation, dxy greater than equal to 1 plus 1 by dxz plus dzy. Now simplify this one, you will get, simplify this one, you will get this. Simplify this one, you will get this. 1 plus dxy by dxy. Okay, greater than equal to 1 plus dxz plus dzy divided by dxz plus dzy. Okay, if I take reciprocal, then this is again dxy by 1 plus dxy. When I take reciprocal, sign will be reverses. This will be now less than equal sign, and here it is dxz plus dzy divided by 1 plus dxz plus dzy. Is it okay? In the right hand side, we know our matrix is defined in this way. d1 xy is equal to dxy by 1 plus dxy. So in the left hand side, I will get d1 xy. In place of this, I am writing matrix d1 xy. And in right hand side, I will separate this dxz by 1 plus dxz plus dzy, then dzy divided by 1 plus dxz divided by dzy. Okay, now we know that 1 plus dxz is less than equal to 1 plus dxz plus dzy. Okay, this will be definitely less than this one. Okay, as this is greater than equal to 0. So 1 by 1 plus dxz is greater than equal to 1 by 1 plus dxz plus dzy. Okay, so if I multiply both sides by dxz, I will get 1 plus dxz greater than equal to dxz divided by 1 plus dxz plus dzy. So in this place, this is less than equal to further this term. Okay, that is, now this is equal to my d1 x y less than equal to, this is further less than equal to this term, so I am writing this term in place of this 1 plus dxz. Okay, similarly you can write this dxz is equal to dzy by 1 plus dzy. In the next step I will take this one. Okay, here you should replace this zy, replace this by zy everywhere. You will get this one. Here it is zy, here it is zy, here it is zy, here it is zy. Then you will get the second one. And we know our function this is equal to our d1 x, okay, plus d1 z. That is d1 xy is less than equal to d1 xz plus d1 zy. Hence d1 is a metric on x. Hence d1 is a metric on x, and x comma d1 is a matrix. Hence d1 is a metric on x. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.